All right, you're going to see problems worded like this. Solve for W when f of W equals 0, where this is, they're not really saying it's f of W, but it is. So even though they're not saying it, you could write it in if you wanted to. F of W equals this, right? But up here it says, hey, make your f of W equal 0. So here's my f of W right here. So let's take it and replace it with 0. So you see it just kind of formulated an equation. It was kind of a long way around, and they could have started with this equation, but they made us do it. Stinking jerks. Hey, now I would look for any greatest common factors to take out of this, but I don't see any. 15 is not a perfect square either, and neither is 3, so that doesn't help us with perfect square trinomial business. So I'm looking for factoring by grouping on this one. So I'm going to take the leading coefficient 15, and then in this case, the constant, I'm going to show it as -3. When I multiply this, I get -45. Now I need two factors of 45 to add up to 4, positive 4 specifically.
Plus 9 to minus 9.
Yeah, that's correct. So we're going to use a positive 9 and a -5. When I add those together, I do get 4. So I'm going to take the 4 W's and split it up into those two values as 9 W's and a -5 W's. Okay, so now I've got, well, 0, but 15W squared. That's a positive 9W minus 5W minus 3. And yeah, I will show the equals 0. But some students don't like to show this yet just because we're kind of focused on our factoring, right? So you don't necessarily have to worry about the equals 0 yet. We will, but not yet. So from here, we're going to let's factor this first group, this pair. So it looks like I know I can factor out a W from there, but also it looks like I can factor out a 3. So 15 divided by 3 is 5, 9 divided by 3 is 3, positive. And then we took out a W from the first term and the second term. This W factored out as well, but that leaves us with no more W's, okay? Now we'll go to the second set, and I got a -5 coefficient to start. So I know I'm going to factor out a negative. Oh, I don't see anything I can really factor out. So I do need a 1 right there. And then I'm left with -5 divided by -1 is 5. That's how many W's. -3 divided by -1 is +3. And you can see, again, our binomials that are left match, which means that we can take those two binomials out and factor them out of what is going to be what's left over from that binomial, which would have been 3W and -1. Okay, now again, this still does equal 0. And in the past, right, for this whole unit, at this point we would have been done, but we got a little bit more work to do. We got to solve these two by forcing them to equal 0. So let's do that. So I'm going to give myself more space first. But I'm going to start with the 5W plus 3. If I could get it to equal 0, then the whole thing would equal 0. And some students say, well, this part wouldn't be 0. That's true. It doesn't matter because this one is. You're going to have 0 times something. I really don't care what this is. It's going to be 0. Okay? So let's go ahead and solve that. Principles of equality, right? So -3 on both sides. Drop my 5W's, which equals now -3. Looks like we're going to end up with a fraction. Then divide both sides by 5. So W, or 1W, equals -3/5. Okay, now, I'm not going to do it, but if you were to replace these W's with -3/5, make sure you put this one in parentheses, because if you don't, the calculator is going to interpret it differently. It's going to interpret it incorrectly. Make sure you put this W here in parentheses when you put it in. But if you replace these two W's with -3/5 in parentheses, you're going to get 0. It checks off. Okay, now that's one of our solutions, but we expect the other binomial, 3W minus 1. If we could make this one equal 0, it should also work. Okay, so let's see what we get. So right off the bat, we'll add 1 to both sides. So that zeroes out. 3W equals 1. Then divide both sides by 3. And it looks like W, in this case, equals 1/3. Okay, now again, if you go back up here, replace your W's with 1/3, boom, you get 0. And then you find that it would be a solution.